This video is going to complete the tower and then add the claw on the end of the arm. Now, as you can see from the instructions, we need to bring our tower assembly in, align it on these two axles, and add shaft collars on the outside. Then after we do that, we will need to affix and add the bolts and the retaining posts to the bottom of the tower like we did on the other side. So in Inventor, let's begin by bringing in our tower section. This is the left tower side. Bring that in. Now I need to align these with the posts here. Just do a mate constraint on the center lines of the hole and the spacers. It's the easiest way to line that up. You can swing that around a little bit, move it around, change my view a tiny bit, and do the other one. Once I have the second one in there, that to that, change my solution so that it accepts it. Now this moves any which way I want. Now you might think you want to push this all the way in to be snug against this piece, but what you really want to do is make sure it's lined up to the proper holes so that you can get the bolts into the holes properly. Okay, now if you look, it looks like that comes close to lining up, and that helps you see which holes you need to line up to. Let me change the view a little bit. Now, this bar currently slides in and out because it's just over the axles. If we want to lock it in place, we just need a flush constraint between these two surfaces. So constrain, change it to a flush versus a mate constraint. Select that, and that snaps into place. And now that side of the tower is constrained. It cannot move. We picked the proper holes. There's a little gap here. Had you used the spacers, it wouldn't have locked in properly down here. Now we also need to bolt these in like we did this side, but it's an identical assembly to what was over here. So if I can select all the parts that we used over here, okay, the bolt, the nut, the spacer, and the two one-post retaining clips, we can just make a pattern. Okay, we can make the pattern go that direction, and I think we need another inch. Yep, so instead of 2 inches, 3 inches. It's exactly where we need it. We click OK, and we have the bolts we need on that side. Moving on to the claw kit. The instructions have you assemble a motor into the basic claw kit, but the assembly that we have in Autodesk Inventor already has the motor attached to it, so we don't need to do that. We do, however, need to place the motor onto the end of the arms. Now, the original instructions had you use a shaft with friction collars on the ends. It's a horrible connection, would often come loose. The bare minimum in class, I recommended you use the locking shaft collars, the metal shaft collars, and you might even want to switch it to a bolt and a nylock. I'm going to assemble ours in Inventor with a bolt and a nylock. If you wish to use a shaft and two of the metal shaft collars, feel free. Depends on which you did in class. So the claw is in the motion folder. It is called Claw Kit -V5. So I'm going to bring the claw kit in. As you can see, it has the motor attached to it. You can bring it up near the front. Now there are some eye mates where we need them to be. We need to lock it in to here and here. Now the arms don't have the eye mates, and they don't have curved surfaces on the outside. Well, it means we can't use the eye mates. But it's no harder than constraining one side to the one of the sides like such. Change your view, go back, show you what that did. Now we just have to line up the centers of this hole with this, and this hole with this. So constrain, leave it on mate, pick the center line. We're just lining up the axes. Change your solution. And do the same down at the bottom to line up the next one. Constrain. Get it out of the way. Pick the two. Edit the solution. Click OK. Now it is constrained in place. We need to add the bolts. To secure the claw to the arm, I believe we need an 1.5 inch bolts. So we'll go to the structures folder, pull up the 1.5 inches. I also need a nylock. It's the best choice. Okay, we can just use an iMate, snap that into place. Swing around to the other side and secure the nylock. To lock the nylock in place, we need to add an angle constraint to the sides of it. But we can't use the sides of the plastic claw as they're slightly out of plane. However, we can change our view, zoom in underneath, and lock it into the end of the C channel. Okay, with that, that nut will not move. Well, it moves up and down with the arm, but it does not rotate. Okay, we need one more nut and bolt combination. I'll select them both and just make a pattern. We'll move it up along the claw 2 inches, puts it perfectly in the other hole. At this point, it looks like we have a completed model of the clawbot. The wheels will turn. The arm is constrained and moves up and down. There's just one more thing we really need to do. If you notice at the top of the arm, when it moves, the gears don't move in sync. And that's an easy thing to do. We should probably address. Now, these planes that show up on the gears are there for a reason. Okay, let me pull this out. We can take a look at it. You can see one of them goes through the space between the teeth and one goes through the middle of the teeth. Same thing on the larger gear down here. We can simply align those planes. So, oops, not joint, I need to constrain. I'm going to pick one of these planes. Let's pick that one. Now if you look closely at that, that is the plane that goes through the middle of the tooth. So I need to pair it up with the plane that goes through the middle of the gap on the large gear. Now the teeth are lined up. However, they won't move. Well, there's a way around that. Got to find that last mate. That's this one. Actually, it'd be easier to find it off that 12-tooth gear. There's less right there. It was mate 25. You see the planes lighting up. I'm going to double click on the name, and I'm just going to change the name of this to Gear Align, just so we have reference to it and can find it. Okay, I am going to add another constraint. This is called a motion constraint. So we go from the assembly constraints to motion constraints. And this allows things to rotate together. I want the gears to counter-rotate, so I need to click the reverse solution. Click somewhere on the gear so that I get that curved open loop. So I'm going to click on that face, and I'm going to click on that face. Now, this isn't a 1-to-1 ratio. It's a 7-to-84 ratio. Or, a 12-to-84 ratio, which reduces to a 1-to-7. So, 12 teeth on the top gear divided by the 84 on the bottom gear. Or you could do 1-to-7. Going to apply it. Now, it still won't work because it is still locked in by the gear align constraint. We simply need to go back to that, and I don't want to delete it. If we ever need to bring it back for some reason, it'll be here. We're going to right click and suppress this constraint. It's there if we need to unsuppress it, but it won't be used. And now you can see when you rotate, they rotate together and the teeth stay meshed. Now, the only other thing really to address is the fact that you can see these work planes that we use. We could find the parts and individually go in and make them non-visible, but we can also just go to the View tab, and on the left there's an option called Object Visibility. It basically is where you select what you want to see in your window. I want to turn off User Work Planes. And as soon as you do that, you will not see any of them. And there is our completed Clawbot.